Devendra. Now, in today's class, we are going to study about accuracy and the errors. Okay, chapter number 2. Okay, I'm gonna share my screen. Yes, beta. Uh-huh. You are not clear. Can you send your message through chat?
सर ये जो टॉपिक है ना मेजरमेंट ऑफ लेंथ और मास वाला
हाँ.
सर ये वाले आपने अभी तक नहीं करवाए ना
किस चीज का है?
रिवीजन क्लासेस में तो सर पहले एक्यूरेसी पढ़ाएंगे और फिर वो वाली.
हाँ हाँ.
ओके सर. और सर मुझे कल जो आपने पढ़ाया था उसमें एक चीज में डाउट है.
क्या था बेटा?
सर ये जो यूनिट की डेफिनेशन है ना
हाँ,
सर ये यूनिट डेफिनेशन की बुक में हाँ वो मेरे को समझ में नहीं आई.
What is that?
Measurement of any physical quantity involves comparison with a certain basic, arbitrarily chosen, internationally accepted reference standard for सर इसमें जो arbitrarily chosen है ना इसका क्या मतलब होता है?
एक मिनट, मैं आपको लिख के बता देता हूँ. So that is not working. Okay, see, what you said. You said definition of unit. As per your book, it
Yes,
is something different. Means any quantity that comparison of the quantity. Okay, now see, like you are measuring something. Like yesterday I have given you an example that you are going to a vendor, a vegetable vendor, and you are asking for 2 kg potato. Then what that person is doing? He is comparing the potatoes with a 2 kg what which is already available with that person. Okay, now same way, if I ask you to draw 2 centimeter line, okay, then what you will be doing? You will be comparing your drawn line with a scale, regular scale, na? So every time for measurement or for doing any calculation, you are comparing the things. Okay, just like as if I ask you to read the chapter for 2 minutes, okay, then what you will be doing? You will be comparing your spend time with the clock. Is it so, na? So every time if we are measuring something, that means we are comparing any quantity, any arbitrary quantity, any random quantity that we are measuring. So we are measuring all these quantities with a standard term. We are comparing them with a already established standard. Okay?
Yes, sir.
Yes.
Sir, ये arbitrarily choosing
Any quantity, beta. On random basis, you have selected any quantity. Okay? Now, see, our next topic is about errors, accuracy and precision. Okay? So here, if I define this accuracy and precision, let's suppose you are measuring time. or you are measuring something, some quantity, and the accurate value, let's suppose on your screen, the screen is visible.
Yes, sir. Yes, sir, it
Okay.
is visible.
You can see here one red circle is there at the center on the target. This is your true value, the most true value that we are going to measure. Okay, now you are going to hit the some arrows over this target, and let's suppose if you hit that arrow and that arrow hits into this white area, okay, then your value is not accurate because you know the true value is 1, that is near this red area. Okay, that means your answer is not close to the true value. Okay, so in this way we are going to define the accuracy. Accuracy means closeness to the true value. That is known as accuracy. And precision means repetition or the degree up to which we have measured the quantity. Got it? So let us see this video, then we will come to know about this accuracy and precision in more detailed way.
Closeness of the measured value to the true or actual value. How close the darts land.
Now you can see here this yellow arrow. Okay, this is hitting the target in the red zone. That means this is most accurate. Okay, so this is the accuracy, that means closeness to the true value, and all other these arrows, they are not hitting the target in the desired portion, so they are not accurate. So accuracy is the closeness to the true value.
To the center of the bull's eye determines the accuracy of the throw. Precision is the degree of resolution of a measured value when the same quantity is measured with different devices. If all 5 darts land at the same point, then the throws are said to be precise. Take, for example, an object whose absolute length is 32.56 millimeter is measured using 2 different instruments.
Now this is an example. Let's suppose our value is, your answer will be 32.56 mm. This is the true value. Okay, and you are going to measure it with the help of 2 different scales. Okay, now these 2 different scales,
then the throws are said to be precise.
now you are going to measure the length of this stick with the help of these 2 scales. You can see there are the difference between these 2 scales. Okay, so if you are measuring it with the help of these 2 scales, you will find 2 different readings.
Take,
okay,
for example, an object using the second.
Now in the first scale, you have measured it and your answer is 32 mm. Okay, now with the help of second scale, you have measured the value.
Instrument with a resolution of 0.1 millimeter. We obtain the measured value as 32.5 millimeter.
Now, with the help of second scale, you measured the answer and your answer is 32.5 mm. Okay, now which one is precise?
32.5.
32.5 is more precise as compared to 32. Now, if we say in terms of accuracy, 32 mm is more accurate or 32.5 mm is more accurate? 32.5 is more accurate because this is more close to the true value. Got it?
Call this M2. Here, M.
Now, see, 32 mm is less accurate as compared to 32.5 mm.
2 is more accurate.
Similarly, they are
as it is
different
closer to
in
the
terms of
object's true
accuracy.
value than M1. Also, M2 is more precise as the resolution of the instrument used is greater than that of the first one. Any quantity that is measured should be accurate and precise. In reality, errors may
Now, let us talk about errors. Now, errors means uncertainty in a value. That is known as the error, or we can say the difference in the true value and the measured value of any quantity. That is known as error. Got it? Error are of two types. One is systematic error and second one is random errors. Okay, on your screen you can see systematic errors. They are one directional errors. One directional error means either they are positive or they are negative. Okay, now random errors, as their name says, they are random. They can be positive, they can be negative at the same time. Got it? In the same set of readings, they can be positive or they can be negative. So they are the very random values. Systematic errors, they are very easy to remove by the help of calculation or by some modifications. We can remove systematic errors, but random errors, they are very difficult to remove. Okay, now these systematic errors are further divided in certain parts.
directional error. That is, it's either positive or negative. A systematic error can occur due to an imperfect instrument, a faulty measurement technique, or incorrect process of measurement. Errors may occur due to the use of an imperfect instrument for measurement. Such errors are known as instrumental error. For example, errors are classified as systematic occur due to an imperfect instrument, a faulty measurement technique, or incorrect process of measurement.
Now, these are the systematic errors. Imperfect instrument, faulty technique, or incorrect process. Okay, so these are the systematic errors. Now, imperfect instrument means there must be an error which is included into the instrument. For example, to determine the temperature of human body, okay, we need to place the thermometer in our mouth. Okay. Now, in another case, like we are measuring the time or we are measuring weight. Okay, but before putting the weight on the weighing machine, that weighing machine is giving a reading 0.1 gram. Okay, that means there is a fault in the instrument. That is the imperfect instrument. Second one is faulty technique. So as I said, we want to determine the temperature of human body and we need to place the thermometer under the armpit, which will give a temperature which is lower than the actual value of the body temperature. Okay, so this is a faulty technique. Third one is incorrect process. We don't know the process. We don't know how to do the experiment. So there are some personal error arises due to this inexperience of the observer. Just like as we are going to measure the time from a clock. Okay, but instead of standing in front of the clock, we are viewing the time with some angle. So there must be an error which is included into the readings. Okay, so those errors are also known as personal errors. Okay, so there are some other errors which are because of the external causes, maybe changing the temperature, maybe the pressure, maybe the humidity, Okay, maybe the wind velocity. There are certain errors which are included into the readings, measurements. Okay.
Errors may occur due to the use of an imperfect instrument for measurement. Such errors are known as instrumental error. For example, if the needle of a simple balance is skewed or bent, it always shows a weight that is more or less than the actual weight of the object being weighed. Errors may occur due to an imperfection in an experimental technique or procedure adopted while measuring. For example, keeping a thermometer under the armpit will not measure the body's exact temperature, as the mercury bulb is exposed to external factors such as air in the room, humidity, etc. Errors may also occur due to an incorrect technique or procedure being followed while measuring values.
Just say na, like you are measuring the length or you are measuring the time. So instead of standing in front of the clock, you are viewing the readings at some angle, maybe from the right hand side, maybe from the left hand side. So you will be finding some different readings. Got it? So these are the personal errors that we have included into the measurement. Got it, beta? Now, I want to ask you one question. So I'm going to share my screen. Now screen is visible?
Yes, sir. Yes, sir.
Okay. So give me the answer. 5. We are having 3 numbers. Okay. Now, what is the difference between them?
So the last one is more accurate than the first and second one.
Last one
Yes,
is?
sir, the first one is more accurate. The second one is more accurate.
The second one is more accurate. Matlab this one. 5.0.
Yes, sir.
Is it so?
We show the third one is more accurate than both of them.
The third one.
Okay, now see, the difference between them is that the number, this is 5, 5.0, and this is 5.00. The difference between these 3 numbers is of the precision. 5.00 is more precise because value is measured up to second decimal point. Okay, this is measured up to first decimal point, and this is most 5 only. Okay, so 5.00 is more precise as compared to other 2 values. Got it?
Yes,
Can you give
sir.
an answer of such questions? Okay, so moving to the next thing.
Such errors are called and by improving the technique or procedure of measurement, be either negative or positive, and the quantum of error will be associated with both systematic and
See,
random errors.
there is a word that is least count. Okay? Least count means the minimum value that can be measured from an instrument. That is known as least count. Now here in front of you there are 4 scales. In these 4 scales, they are used to measure the length. Okay, the only difference between these 4 scales is of least count. In the first one, least count is 1 centimeter. That means minimum value that we can measure out of that first scale is 1 centimeter. So least count is 1 centimeter. In the second scale, minimum value that we can measure is 0.5 centimeter. So least count of this scale is 0.5 centimeter. Similarly, in the third one, the least count is 0.2 centimeter, and the last one, that is least count is 1 mm. That is 1 mm is the minimum value that we can measure from this instrument. Okay, is it clear? Least count.
Least count is the smallest value of measurement that can be measured using an instrument. All values are considered in as the arithmetic when a quantity is derived absolute error s or divided b by in the r. We are not sure this is a first rule, which 5, then 1 7, which number 250 in scientific notation as 2.50. Latter is considered 1.6 SI system of measurements.
Now
While the
we are
others
going
are
to write the
derived physical
dimensional formula of any
we
quantity.
get 0.1527.
So for writing the dimensional formula of the quantity, we must know the formula or the unit, any one of the thing. Either formula must be known to you or unit must be known to you. Is it clear? Now we know that there are various quantities which are available to us, and in yesterday's class we discussed about the 7 fundamental quantities. Okay, apart from those 7 fundamental quantities, we can make other units, and those other units are derived units. So in front of your screen you can see
SI system
volume,
measurements.
density, force, momentum, work, energy, area, all these are the derived
While the
units.
others are derived physical quantities.
Okay,
So
these were the 7 fundamental quantities: length, mass, time, electric current, thermodynamic, temperature, amount of substance, and luminous intensity.
then fundamental quantities are
Now if we are
length,
going to write
thus of the base quantities.
the derived quantities, so let's suppose key velocity. So we have discussed this as well, how to derive the unit. Yes or no? But how to write the dimensional formula? For the dimensional formula, dimension means the power of mass, length, and time is raised. Okay, that power is known as the dimension. Is it clear? Dimension means the power of the length, mass, and time is raised up to which dimension? Means the physical quantities are the powers to which the unit of base quantity is raised, and base quantity is mass, length, and time. Is it clear? So you can write down the definition as well. I'm writing on this. Okay, if I'm writing on the screen, you can write down the definition of that dimension as well. Dimension of physical quantity are the powers to which units of base quantity are raised. more thing about this dimension is, at the time of writing the dimension, we are supposed to use the square brackets. That means these brackets. Okay. And all the dimensions can be written in L, M, and T, or the other 7 fundamental quantities that we can use. Just like as we are going to write the dimensions of force, or simply we can say speed. What is the formula for speed? Speed is equal to distance divided by time. Okay. What is the unit of this speed?
Meter per second.
Meter.
Meter per second.
Unit of distance, this is meter, and unit of time is second. Okay, so the dimension of this quantity speed we can write in this way: m raised to 0, because m represents here mass. Okay, this is L, that is length. So here length is 1, and T raised to minus 1. Here it is 1 only. Na? In speed, unit is meter per second. Meter, it is represented by length in the dimensional formula. So dimension of this speed is like this: m0 L1 and T minus 1, square bracket close. So this is the dimensional formula of speed. Got it? Similarly, we can write the dimensional formula of other physical quantities, just like as I want to write the dimensional formula of acceleration. Okay, so acceleration is equals to, yesterday we derived the unit
Velocity dividing by time.
v by t, and this is the formula. So unit is meter per second square. Okay, so dimensional formula will be m0 L1 and t minus
2.
t minus 2, and bracket close. So this is the dimensional formula of acceleration. We can write here as well. This is m raised to power 0, L raised to power 1, and t raised to power minus 2. Got it?
Yes.
So this is the dimensional formula of acceleration. Got it, beta? Yes. Similarly, we can write the dimensional formula of force. What is the formula for force? Mass into acceleration. Hai na?
Yes, sir.
Mass into acceleration. So mass of the quantity will be 1. And acceleration is L minus 2, LT minus 2. So dimensional formula of force is M1 L1 T minus 2. Okay? Sir? This is for acceleration and this formula is for force. हाँ बेटा, yes.
सर वो 10th क्लास में रिफ्लेक्टिव इंडेक्स पढ़ा था, उसका डायमेंशनल फॉर्मूला क्या होता है?
बेटा, there is no dimensional formula of refractive index, because this is a ratio of the similar quantities. That was the ratio of speed of light in vacuum to the speed of light in medium. Okay, see.
Okay, sir.
सर मतलब वो
That was
डायमेंशनलेस.
that is dimensionless. Mu is equals to c by v. Okay, the dimensional formula of speed is that speed of light c, that is l1 t minus 1. Okay, and similarly in the denominator it is l1 t minus 1.
T minus.
Okay, so they are cancel out with each other. So there is no dimensional formula of refractive index.
Okay, sir.
Got it?
Yes,
So
sir.
rest we will be doing in the next class. There is a table of dimensions in your NCERT book at the back. So you must write down the first 20 dimensions in your physics copy. Okay?
Okay, sir.
Okay, beta. Thank you.